Hello and welcome back to our next maths video. Now today's lesson we're going to look at adding and subtracting fractions. Now we did look at this last year and actually this is easier than you think. So we've worked hard on comparing fractions, equivalent fractions and mixed numbers. And this is just using that. In fact, I think this is easier than comparing fractions because there's only one thing you have to remember when you're adding subtraction fractions, and that's remembering that you can do adding subtraction fractions and only have to think about the numerator if the denominators are the same. So as long as you've got the denominators the same, it should be nice and easy. We do move on to the fact that sometimes you have to find the same denominator, but for today, the majority of the questions you'll see will all have the same denominator. So you only really have to pay attention to the numerators and maybe using your knowledge of mixed numbers to convert between improper fractions and mixed numbers. So let's have a look. First couple of questions. Have a look, see what you can do. Pause now and see what you can do. Okay, first question, hopefully nice and straightforward. I have 5 apples. Sorry, 5 apples. This apparently doesn't work with these weird fingers here. 5 apples plus 2 apples. How many apples do I have in total? 7 apples. The same works in thirds. I have 5 thirds plus 2 thirds. I have 7 thirds in total. And this could obviously, should obviously be written as 5 thirds plus 2 thirds equals 7 thirds. And here's the key. What happens with the denominator? Nothing, absolutely nothing. It stays the same across the entire thing. As long as these two denominators are the same, this one stays identical. And if they're not the same, you make them the same and the denominator doesn't change. So the rule when you're adding subtracting fractions, the denominator stays the same and you just work with the numerator. And that's it. 5 plus 2 equals 7. We're talking about thirds, so they stay as thirds. We're not changing what they are. Let's have a look at this in terms of 7 ninths minus 4 ninths. Here is 7 ninths. 1, 2, 3, 4, 5, 6, 7. And there's 9 in total. I'm taking away 4 of them, surprisingly enough. I just cross 4 out. What am I left with? Well, I'm left with 3. The ninths are still ninths. There's still 9 of them in total. We've just reduced the amount we have of them. And that's all we're doing. So 7 minus 4 is 3. We're just talking about them in terms of ninths. The same here, we're talking about them in terms of 11ths, but we're doing 8 minus 5 minus 1. So 8 minus 5 minus 1 gives us 2. So the abiding thing that we have to remember is when we are adding or subtracting fractions, make the denominator the same, and then just deal with the numerators. And that's it. But let's go through and try and see whether that works for us, whether there's anything else we need to pay attention to, sometimes with mixed numbers and that sort of thing. So maybe we need to think about that, but let's have a look. So Dexter eats 2/5 of his chocolate bar. Alex eats 4/5 of her chocolate bar. Do they eat more than one whole chocolate bar altogether? Numerous ways that we could do this. First, we could draw a diagram. So Dexter's is the top, he's eating 2/5. Alex is the bottom one, and she's eating 4/5. And then we're just working out whether these two together is more than one. Well, that's the same as saying 2/5 plus 4/5. So how many fifths do we have in total? Well, you can see it straight away. 6/5 is 6/5 more than 1. Well, yeah, and look, watch. There it is. That's our 1. We've still got 1 left over, so it'd be 1 and 1/5. So this here is just our improper fraction, isn't it? It's just moving from improper fraction to a mixed number. And the addition is 2 plus 4 equals 6, keeping the fifths the same the entire way over. So hopefully you're not looking at it going, oh my God, I can't do this. Hopefully it's not that, because actually the maths involved is pretty simple if the denominator stays the same. I mean, the tricky bit really is remembering our mixed numbers. And if you are struggling with that, stop now, go back and watch that video about mixed numbers again, just refresh your mind, then come back and see if that helps. If not, we'll talk about it. Really easily, it is 6 divided by 5, which is what 6/5 is. I can fit one whole 5 in with one left over. Because I'm dividing by 5, that one left over is the same as saying 1/5, because I'm dividing by 5 and I have 1. And you can do that for any of them. If you did 12/5, for example, how many 5s can I fit into 12? I can fit 2 in with 2 left over. I'm dividing by 5, so that's the same as saying fifths. I have 2 left over, so that's 2/5, and I have 2 of them. It's 2 and 2/5. As long as you know your division and you know how to divide with remainders, they're never going to give you a really hard one to do, so I wouldn't worry too much. The numbers are never going to be massive, but this does work. So have a look at this one, see what you think. Okay, so 3/7 plus 6/7. So quick maths on the side. 3 plus 6 equals 9. Let's just check we're right, shall we? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's definitely 9 of them in total, and these are still split into 7. So it's 9/7. Then we can do our whole thing of how many 7s fit into 9. Well, that's so 9 divided by 7. We have 1. How many do we have left over? 2. So we're thinking this is probably going to be our 1, and then we're divided by 7. So that's over 7, and we've got 2 of them. So 1 and 2/7. Well, also, if we just move that one here, there's our 1, and there's our 2/7. And there we go. Lots of different ways to get to the same answer. You can draw it. You can just use the pure maths in your head to do it. You can do some working out. Whichever way works for you is the way I would suggest doing it. Then as you keep trying that, you will notice the shortcuts. You'll see that, oh, I don't have to do all of this. I could do this and this would make it easier. And actually that makes it more purposeful, you seeing the tricks rather than me just telling you them. But I will continue too, don't worry. So another way to show it, changing 9/7 into a mixed number, is that you could take 7/7 out, which is the same as 1, and that leaves you with 2/7. 7/7 is 1 because the number on the top and the bottom are the same. So that's 1, and we have 2/7 left. So that's 1 and 2/7. Or you could do this method, depending on which way works easiest for you, or draw a diagram if that way works easy for you too. We've got 3/8 plus 3/8 plus 7/8. So the first bit of maths we do is just add them together. So 3 plus 3 is 6 plus 7 is 13. They are still 8s. Okay. Then we need to think about how many we fill in. So the first thing you could do is a Pothole model if you wanted to show it this way. You do 13. So I need 8/8 first. I can take those out. And that leaves me with 5/8. 8/8 is the same as saying 1. So that would be 1 and 5/8. The other way to go about it would be 13 divided by 8 equals, I can get one whole one in with 5 left over. That 5 is the same as saying 5, and the math piece I have is 8, so 5/8. Or I can draw out my whole, split it into 8s, like so. I've got 13, so I know this is more than 1, so 13 is more than 8, so I can then split it again. There we have it. Then I need to fill in 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5. And then we also have our 1 and 5 eights. Lots of different ways to get there. Any way does work. The quickest is this one. But this one very definitely gets you to the answer, and so does this one. So have a think about this one. Okay, first with maths, we have to do 8 plus 10 plus 6. 8 plus 10 is 18, plus 6 is 24. Remember, when we're adding or minusing fractions, the denominator stays the same, and we just deal with the numerator. That's that bit. Then we can go through all of our different ways of finding it. So we can do a pothole model. So the first one, we take off one whole one, which is 11. I still actually have enough to take another 11 out. So there's my 1. And then I've got 2 left over. And actually, that could be more confusing. 24 divided by 11. Go through my 11 times table. 11, 22, can't go any higher. So it's definitely got 2 in it. That gets me to 22. I have 2 left. That's the same as saying 2 remainder of 11. 2 of 11, 2 11ths. And yes, you could draw out a diagram to show the same thing. So our answer as a mixed number is 2 and 2 11ths. Now, to be honest with you, sometimes they just ask for the answer, and they won't. If they specify that it has to be a mixed number, you have to write it like this. If they specify that it has to be an improper fraction, you have to write it like this. But if they don't, just leave it as the easy one. Why make your life harder? So now we're on to subtraction. So first we need to set up 11 eighths. So this is a bar with 11 in, this is a bar with 11 in, and guess what? We're going to take away 2 of them. There we go. The 8 doesn't change again. So the denominator stays the same, and we just deal with the numerators. 11 minus 2 is 9, so it's 9 eighths. You can see that here. That's over 1, because there's my 1, with 1 left over. So 1 and 1/8. How about this one? You try it, see what you think. Okay, hopefully this is all right. We've got 7 quarters. There they are. 1, 2, 3, 4, 5, 6, 7. I'm going to take away 1. Whoop. How many do I have left? 1, 2, 3, 4, 5, 6. Surprisingly enough, it's the same answer as 7 minus 1, isn't it? 6 quarters. 6 quarters are the same as 1 and 2 quarters. Or you could write it as a pothole model. Take your 4 quarters out, which is the same as 1, and your 2 quarters. So the full 4 quarters becomes 1, and you've got 2 quarters left. And there we go. The 2 quarters is the same as a half. You can see that because this would be the same as a half here. So you could write it as 1.5. You could do it as 6 divided by 4 equals 1 with 2 left over. 2 quarters is an equivalent fraction. 4 2 divided by 4 even is a half. So that's the same as a half there. Or you can do 4 divided by 2. You just know that both of these can be divided by 2 to get to this one. Like that. And that's the reason why all of this works. But you can see that actually the subtraction is the easiest part. And unless they're asking it particularly as a mixed number, can you leave it as this? Yes, you can. But quite often questions are quite specific in the way they want you to show it. So have a think about this one. So first off, we can do our first part, which is 21 minus 2, which is 19. Then we take away the final 3/5, we get to 16/5. Then we're going to think about that in terms of a mixed number. 5 times 3 is 15. That leaves 1 left over. So we get that. So if you were going to write this out, you do 16 divided by 5 equals 3, remainder 1, which is the same 3 1/5. If you were going to do it as a Pothole model, you could take away 5/5 there. You could take away another 5/5. You could take away another 5/5. You're left with just 1/5 left. There it is. Check, we got still 16, 5, 10, 15, 16. We're good. This is the same thing as saying 1. This is the same thing as saying 1. This is the same thing as saying 1. We've got 1, 2, 3, and 1/5. Whichever way you go about it, you can get there in lots of different ways, and whatever way works best for you is the way to do it. I would suggest if you know your times tables and you've got your times tables, using them is your road to success, your trick of making fractions as easy as they possibly can be. Now, Pothole models, like I just showed you, work nicely. You can do the supplement and work your way through that. But in order to do that, you kind of have to do maths as you go along. So you'll do, okay, take 5/5 out. That leaves me with 11. I can take another 5 out. That leaves me with 6. I can take another 5 out. That leaves me with 1. That's in that 1 on the zone. So I've got 3 5/5. Each one of those is 1. That's 3 in total. And then the 5/5 can be a little confusing in your head. Or you could draw a diagram, and that would work as well. So here's your first set of questions. Pause now and have a go for me. Okay, so we've got a few here to work on. Let's just have a quick look through them. I'm just going to go to the answers and then we'll talk through them. So question 1 says use a bar model to help. So we're talking in fifths here. So we've got 4/5 plus 3/5. So you draw a bar with 5 in it and you will fill in 4, 1, 2, 3, 4. Then you add another 3 on. So you've got 1 and then draw another bar of 4, 5, 2, 3. And then you can work out you've got 7 in total. 4 and 3 added together is 7. Or you've got 1 whole 1 and 2/5. The same here, still working in fifths. So we've got more fifths here. We've got 6 in total plus the 3, there it is, which is 9. Or 1 whole 1 and 4/5. If we're going the other way, we've got 8. So 1, 2, 3, 4, 5, 6, 7, 8, what we start with. Then we're taking away 6 of them. 1, 2, 3, 4, 5, 6. That leaves us with 2, which just happens to be the same thing as 8 minus 6. So we've got 2/5. And then up here, we start with 9. You can see it's just underneath me in the corner over here. We're taking away 3, so we cross out 3 of them. We're left with 6, which is 9 minus 3. So we've got 1 whole 1 and 1/5. Just remember, if you look, all of them, does the denominator change? No, the denominator stays the same the entire time. That's the trick. Complete these. So we're thinking in sevens, so put 7 here. 4 plus 2 is 6. Talking in sevens, 7 goes underneath. 4 plus 3 is 7. 7 sevenths is the same thing as 1. Thinking in sevens, so 7 goes on the bottom. 4 and 4 is 8. 8 as a mixed number, we can take 1 lot of 7 out and be left with 1. Then we're thinking in sevenths, so it stays on the bottom. 8 minus 3 is 5. Thinking in ninths, so ninth stays on the bottom. 7 plus 8 is 15. I can take one group of 9 out and have, so I'll show you where this comes from. Here's 15 divided by 9. I can take 1 out and be left with 6 ninths. Sorry, 6 ninths. Now 6 ninths, both of these two numbers are divisible by 3. So I will divide both of them by, both of them by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And therefore, you have 2/3, which is where the 2/3 comes from for the 6/9. Okay. Then we come up here, we've got 9ths, and we're doing 17 minus 8, which is 9, which is 1 in total. Thinking 9ths, so 9 stays on the bottom. 16 minus 8 is 8. Thinking in 9ths, so 9ths stay on the bottom. 7 plus 2 is 9, plus 8 is 17, and our equivalent fraction is 1 and 8/9. Equivalent, our mixed number. Thinking in 15ths, so 7 plus 2 is 9, plus 8 is 17. Mixed number, we have one full set of 15 plus 2 extras. Thinking in 15ths, now be careful here. This is subtraction here, and this is addition. So 7 minus 2 is 5. 5 plus 8 is 13. 13/15. That's where that comes from. Now, question 3 said, what could the missing numerators be? 6 different possibilities. So we're thinking in 8ths. You can see the 8ths are all the same here. So actually, it's any combination you like of two numbers that add together to make 13. And that's it. So you can have 1 and 12. You can have 2 and 11, 3 and 10, 4 and 9, 5 and 8, 7 and 6. All of those added together make 13. And it's just remembering when we're dealing with numerators, we just deal with them like we normally would. So here's a problem for you. We're thinking in 5ths. We have 4 as our answer. So as we're thinking in 5ths, actually the easiest stage at this point to do is to convert that 4 into 5ths. So 4 whole ones are 4 lots of 5/5. Yeah, 4 lots of them. So that's 20/5. Okay. Yeah. Then we can think, okay, so we have to do the opposite of what we've done before, because we're going from the answer back to the starting number. So we have to do the opposite of the subtraction. The opposite of subtraction is addition. So we add 7/5 onto it, which is, add the 8/5, which is 28. Then we add the 7/5, which takes it to 35. And it's just working the other way from our answer, which is 20/5. Rather than subtracting, we add each of the bits that we subtracted to find the initial number that we started with. So this is another way. So this is one way they can give you the answer and give you a missing number, which you have to go back and work through, and as long as you know the inverse. This is another way they might do it. They might have one side of an equal sign and another side of an equal sign, and you've got to balance the two sides. So the first thing you do is you find out what one side is. So 5 halves plus 1 half equals 6 halves. And what I would do at this stage is convert that to a mixed number. So that's 3. Yeah. Then we're thinking in 9ths. So we have to work out what our target number in 9ths is. So what's 3 whole numbers in 9ths? Well, 3 in 9ths is 27. 3 times 9 is 27. So 27/9 is the same thing as 3. So what I want the total being on this side here is that 27/9, because the total on this side is 3. Yeah, so these two must equal each other on both sides. So I've got 14, so I can take 14 away from 27 and I get 13. So it's 13/9 plus 14/9. Those two added together equal 27/9, which is the same thing as 3. And on this side, the two added together are 6 halves, and together that is 3. So this is worth 3, and this side is 3. 3 does equal 3. And that's the way to do it. It's like balancing a scales. Whatever's on one side of the equal sign must equal the same thing as what's on the other side. So you've got to balance them out. You've got to work out what's on each one and make sure they're the same. So here's two problems similar to that. Have a go. See what you think. Okay, let's have a look. So the first thing, like we said before, we work out what 4 is in sixths. So 4 times 6 is 24. So we've got 24 sixths. We've got 29. We're taking some away. How many do we need to take away in order to get to 24? That's 5. Then the bottom one down here, we've got that equal sign. So we've got to balance our two sides. So we work with the side that we know first. So that equals 15 thirds. 15 thirds is the same thing as 5 whole ones, yeah? Because 15 divided by 3 is 5. So on the other side, this side must also equal 5. So 5 in terms of tenths. So 5 equals, I'll probably actually do it for me. 5 equals 50 tenths, because 5 times 10 is 50. So we've got 17. So what plus 17 equals 50? It's 33. And that's our missing number. So we might also come across these as a written question. So we have Mo and Tommy each have a jug of milk. Lucky them. I'm not a particular fan of milk on its own, but lucky them. Joe's mug contains 5/7 litre less milk than Tommy's. So Mo's got 5/7 less than Tommy. The total milk in both the jugs is 3 2/7. Okay, so I need 2 amounts, and we've got to work out what Mo has. So Mo has less than Tommy. Okay, so we've got 2 amounts. We've got Mo and we've got Tommy. So this is known. We know that Mo's got less than Tommy. We also know the difference between the two of them. So the difference, the space from this bit here to this bit here, that is 5/7. We'll see how this works it out, but that's the piece of knowledge we know. So, and altogether it equals 3 2/7. So what we can do is think about the fact, if that's the difference between the two, if I follow that line all the way down here, like that, then these two parts are the same, this bit and this bit. And this bit here is the same as that 5/7. So this is 5/7. So what I can do with this part is I can take away that 5/7, and that leaves me with just those 2 bits left. I can just take away that 5/7. So we do that. So 3 2/7 minus 5/7, that's 23/7, because 2 times 7 is 21. 3 times 7 is 21, plus the 2 is 23, minus the 5 is 18. Now, the other thing to remember is, so these two added together are 18. They're the same, yeah? Because you can see the line goes down here. These two parts are identical. So with the 18/7, we can split it in half, 9/7 in each part. So the answer to the question of how much milk does Mo have is 9/7. Now, if we wanted to, we could check our answer to see if we can get back to the original whole amount. So Mo has 9/7. Tommy has that 9/7 plus this 5/7. We're thinking in sevenths. Good job too. We've got 9 plus 9 is 18, plus 5 is 23. 23/7 is the same thing as 3 2/7. So our total is still right, and that's the way we go about it. This is harder. First off, in your head, you have to work out how you're going to draw it to help you make sense of the question. Secondly, you've got to think about what's the maths I'm doing. That's difficult, but we can get there. then how do I apply what I know in order to answer the question? So this is the hardest part of this entire lesson. The main aim of this lesson is just to add and subtract fractions. So I am happy if you can do that. I'm exceedingly happy if you can do a question like this. So let's have a look. Try these questions for me. Pause now and give it a shot. Okay, let's go through the answers. So first one, number 4. Dora has 2 3/8, and she pours out 9/8. How much does she have left? So the idea would be you do 2 3/8 minus 9/8. She's pouring it out. Now we've got to say what 2 and 3/8 is the same thing as. 2 times 8 is 16, plus that 3 is 19. Minus those 9/8 equals 10/8. I can get 1 whole 8 out of that and have 2 left over. So I could write the answer down like this and that'd be fine. But this 2/8, both of those two actually can be divided by 2. So it can be simplified because I can do the same to the top and bottom. And that gets me to 1 1/4. So this is all about balancing. So 8s are all the same. 13s, 3 in what equals 13? It's 10. 13 minus something equals 6. Equals 7, sorry. The answer is 6. 13 minus something equals 1. Well, 1 is the same thing as 8 eighths. So 13 minus something equals 8. That's 5. Then we've got 2 steps. So we're adding 2 numbers together to get to 22. We've got 11. So that's 11. And then we're doing our mixed number. So how many 9s can I fit into 22? Well, I can get to 18, which is 2, and have 4 left over. So that's 2 and 4 9s. It's already told you that. Look. Then we've got 9ths. And we've gone here. We haven't got what our target number is. So we have to convert this down. So 2 9ths, 2 whole 9ths is 18, plus 2 is 20. Then I can know what I need to add on. This is subtraction, the same thing. So we know what our target is because it's the same thing as this one. There it is. And then we go from 22 down to 20, which is up to minus 2. This is 2/7, 2 whole ones. So 2 whole ones is the same thing as 14/7. So then 4 plus 4 is 8, plus 6 is 14. This again in 7ths, 2 of, so it's back to 14. So we're just thinking about 5 and 5 and 4, 6 and 6 and 2. This is 3 now. So 3/7 is the same thing. 3 times 7 is 21/7. So in this case, they're just in relation to that. And then this is 4. So 4 times 7 is 28. So our target number in this case is 28. What's the missing number? Okay. And then on to 6 and 7. Here are some fraction cards. They're all in 8s. That's useful. But remember, there's that 1 there. Use the fraction cards to write pairs of fractions with a total of 2. So 7 and 7/8 plus 1/8 is 2. 13/8 plus 3 is 2. 9/8 and 7/8 is 2. It's just trying to find the pairs. Then this is the harder one here. So Annie and Dexter both have a skipping rope. Nope. Annie has 3/4 of a meter shorter than Dexter's, and the ropes together are 13/4 altogether. How long is each skipping rope? So again, we would draw out the bars. There they are. Annie's is shorter than Dexter, so that part there is 3/4. So we take our 13/4 minus that 3/4, which equals 10/4, like that. And then we can know that we split it in half, so we've got 5/4 there, 5/4 there. So Annie has 5/4, 5/4 quarters is the same thing as 1 1/4. And then Annie has 5 quarters plus the 3/4, which is 8 quarters, which is the same thing as 2. Well done if you got number 7 right. Thank you for the lesson. I hope that was okay, and we'll see you in the next lesson. Goodbye.